Welcome to Engineering Workshop. Today we will be performing a step turning exercise in lathe machine. So please see the image on the board. You can take down this figure. You could see we will be performing a step turning exercise on a mild steel rod 25 mm diameter. The length will be between 50 to 100 mm. So we'll be making two steps, one with the 23 mm diameter and other with the 21 mm diameter. The lengths are also given, and after that we will be making a chamfering of 2 into 45 degree. That means for a 2 mm length, 45 degree angle, we will be making a chamfer at the end. And for these operations, the tolerances are also given. For diameter, the tolerance is plus or minus 0.04 mm. And for lengthwise, the tolerance is plus or minus 0.1 mm. So your work should be within these tolerance limits. So let us continue with our work. Please keep watching the video.
So here in our this machine shop lab, we have different types of workshop machines here. So one of the important machines of this lab is a lathe. It is a lathe, and today we are performing some operations, basic operations on this machine. So the main parts of this machine, so number one is headstock. This is the headstock as an important part of this machine, and another one is tailstock. This unit is called tailstock, and there's some gateways is there, that's called a lathe bed. So on the lathe bed, the carriage will slides on the lathe bed. It's called the whole unit is called a carriage, and the bottom part of this carriage is called a apron box, and on top of the carriage we have a cross slide. So cross slide means the y direction of the tool movement. So actually lathe is a 2-axis machine, and we have a x direction and a y direction. X direction, we can move the apron, but the whole carriage we can move left to right through the gateways. That means the lathe bed. And top of the carriage we have a cross slide, that is the y movement. That is the control of this is a lever for the cross slide. This is for the carriage. On top of the carriage we have a compound dust. This compound dust is used to make taper turning. Then we can set some angle. We can lose these two nuts we have, so they can just lose it, and we can select a particular angle for the taper turning. Then top of this compound dust we have a tool post. Tool post is used to fit the tool. We can fit more tools at a time. So this is a tool post for holding the tool. And about the headstock, headstock is the main part of this lathe, and the bottom part of the headstock we have a 3-phase motor already fitted on the bottom part. So that's to power the machine. So from the motor we have in between that we have a gearbox. So from motor to gearbox we have connected with a V-belt. After that we can gearbox, from gearbox to the spindle, some gear are connected to the spindle. So end of the spindle already there's one part this called a chuck. So chuck is used to hold the workpiece, is a work holding device, that's called a chuck. And this about the gearbox, we have two levers for adjusting the RPM of the chuck. We can adjust the RPM. So actually we have some speeds already. So the table is here. So from minimum speed of the lathe is 45, and the maximum speed of the spindle is 1120. So with the help of this chart we can select 45 to 1000 RPM here. So for now we are selecting 450 RPM. So 450 RPM means according to our workpiece and tool we are using, and we need to select the RPM for that particular job. So this is a mild steel. Our workpiece is a mild steel and a very soft material, and diameter is only 25 mm. Actually the speed depends upon the diameter and the tool we are using. So this is a 25 mm diameter only. So for that we can select between 500 to 600 we can select. So in this lathe we have a 450, the range, that range. So for selecting 450 RPM we need to select the two gears, two levers are there. So these two levers we need to select B and M. So this lever is in B and this one is in M. So already we have the mark. So BM means you need to already the spindle speed is 450. So for minimum speed 45 means AN. And maximum speed 1120, we need to select the BP. So according to that chart, we can select the speed. RPM of the chuck at spindle. So that's the use of that gearbox. So another some controls are here. So that control we are using for automatic feed and thread cutting for this machine. So that some different type of operation we can do. Now we are only the basic operation doing here. That's phasing and step turning. And another operations are we can do the thread cutting and taper turning, knurling, and different types of operation we can do. So one of the important machines in machine tools. So this is a tailstock. So tailstock, mainly tailstock is used to support the long, lengthy workpieces. Now we have only, this is only 50 mm length. So we can do up to this much of length also we can machine. So for that lengthy workpiece we need to support. On one end we can hold on the chuck and other end we need to support using tailstock. So for supporting tailstock, the face, you need to first do the phasing and you need to drill the hole of 5 mm or something using different drill bit. You need to drill the hole, and that drill hole we can support by using this revolving head, a revolving chuck. Revolving center. Using revolving center, we can support that this much of lengthy workpieces. And after that, this tailstock is used to drill the hole also. That we can simply remove that center, the revolving center we can remove. Then we can hold to drill chuck. We can insert here, and using drill chuck we can drill the holes through the axis of the workpiece. That also the use of this tailstock. And another one more use, the tailstock is also we can use for lengthy taper turning also, that we can shift the center axis, we can shift, and we can do the taper turning also using this tailstock. So mainly it is tailstock is used to support the lengthy workpieces and drilling holes through the axis. And about this apron box, sorry, the cross slide. Cross slide is the Y direction of the tool movement, that we can do the phasing, and we can give the depth or something. That's the main part. There's a moving part. Moving part means a sliding through the lathe bed. This is a lathe layer. We have this lathe bed, the hardened space, hardened face is here. Then after that we have a lead screw. This is a lead screw. So lead screw is mainly we can use for thread cutting and automatic feed, like that. That we can set the lever according to how much speed, how much feed you need, and how much the pitch. According to that pitch and other thing, we have some table here, and according to the table we can adjust the lever for particular job. That's the main parts and main operations of this machine. Then we can start the work. We can follow about this some basic operation here. We need to. This is our workpiece. Actually, this length is about 50 mm, and the diameter is about 25 mm. So we can make some simple step turning. So first do the phasing and introduce diameter and make a step here also. That also we need to make. So that's a simple operation we can study. This is a work holding device called a chuck. So this chuck has we have 4 jaws here, that each jaw will move independently, and using this chuck key we can rotate this one. Each jaw will move up and down. So we can easily fit that to a workpiece here, and you can fit it here. All jaws will be rotate. So you tight all jaws. So in this 4-jaw chuck, the problem is we need to center. First, you need to center the workpiece. Now there is some you can see there is some eccentricities there. That means this is not in center. So we have in this lathe we have an imaginary axis through this center of the chuck to the center of the tailstock center. We have an imaginary axis. So our workpiece also have an axis. So both axes you need to coincide. That means the centering. So for centering, that you need to adjust the 4 jaws. So we can see we have some circles are here. With the help of the circles, we can first adjust these 4 jaws in equal position. So after that, we can fine adjustment we can do with this surface gauge. So this is a surface gauge for using for centering. Though we can locate this needle near to the workpiece, on the face of the workpiece, and near to the chuck also. We need to place it there. Then easily, slowly we can rotate this. So we can see some portion the needle will touch, and some portion there is a gap. So look, we can see some gap is there. So that gap we need to adjust. So where there is a gap, So that jaw you need to loose, just loose it. And the opposite jaw, this jaw you need to tighten. This jaw you need to tighten. So then the workpiece moves down and it will going to that center of the lathe. So again we can check. So there is a slight gap is here. I just loose it. So it is a simple operation. We can easily center the workpiece to the lathe. Easily we can adjust these 4 jaws. So finally we need to tight all jaws equally. Finally, we need to all jaws we need to tighten it perfectly. Otherwise, while working, it will come out. Workpiece will come out. So now it is almost in center. Okay. Now it is almost in center. So centering is over. That is the first operation. We need to center the workpiece. So after centering, we need to fit the tool also. So this is a tool we are using. So V-shaped tool. This is a tip of the tool. And actually this material is high-speed steel, very hard material, high-speed steel, HSS. So our workpiece is on a mild steel, a soft material. So we can use this HSS tool for machining this workpiece. So we need to fit the tool here on the tool post. So before that, we need to add some packing pieces or small metal pieces below the tool for that height adjustment. So that means centering of the tool. That means centering of the tool means you need to center this tool tip to the center of the axis of the workpiece. That you need to center. Otherwise, while facing, you know, face some problem. So we need to center the tool also. So actually, we have a space adjustment packing pieces are here already made. So that you can place it there below the tool. Then after that, you need to tight it well using this tool spanner. We need to tight the key here. Already fit the tool and already fit the workpiece also. Then we can start the machining. So first machining operation is the facing. This is a facing operation we need to do. So facing operation means we need to machine this face. So for facing, you need to adjust this angle. The suitable angle you need to select. That means you need to touch this center to the face. In this portion, the tool tip will not touch on the face. So I need to select the angle. For suitable angle, we can select for machining. So now it is touching. We need some clearance angle between the face and the tool edge. And you can lock it well. Then you can start the workpiece. So the switch is here. This is a switch for this machine. We have 2 positions here. Okay, this anti-clockwise direction you need to switch on the anti-clockwise direction, this direction. Then you can start the machining. So slowly you can touch the tool on the face there, slowly using this lever. Using this lever, you can touch the tool on the face. So now it is touching. So that is a touching portion. After that, we can give some more depth from 0 to this direction using this lever. You can give some depth. And using this cross slide, we can move going Y direction. So the tool will cut the material. This operation is called facing. Machining of the face. That is called the facing operation. The first after centering, you need to do the facing. This is the first operation. So we can give some more depth. So this operation is called facing of the machine. So we can start the work after already facing operation is over. After facing, you need to reduce the diameter for this diameter. Actually, this is almost 25 mm diameter. According to our drawing, it reduced to 23 mm. So for that 35 mm length, it reduced to 23 mm. So first you need to mark the length, 35 mm length you need to mark from this face. So for marking this length, you need to select this using vernier caliper. You can take 35 mm here. 35 mm means 0 is coincide to 35. So you take 35 mm and using this tail length, you can mark the 35 mm length here. So just coincide the tool tip to the tip of the vernier caliper, just coincide. Just keep it there on the tip of the vernier caliper. All the tool tip and the vernier caliper tip already coincide here. And remove that vernier caliper. Switch on the machine and just mark the length. So we'll get a line there. So this length is 35 mm. This is 35 mm length already marked. 35 mm. So up to the 35 mm length, you need to reduce the diameter of 23 mm. According to our drawing, 23 mm diameter as the first turning. Then for that 35 mm length. So for reducing diameter, first you need to start the machine and touch the tool to the workpiece face. Just touch it. So now it is touched. So that touching portion, you need to set this dial to 0. So this dial, independently we can move this dial. So this dial you need to set to 0. So that is the touching portion. Setting of this surface. Tool point is touched to the face surface of this workpiece. That is 0. So you already dial set to 0. So from 0 we can give the depth. So this is almost 25. We need to reduce 2 mm in diameter for making 23 mm. So here we have some chart is there. So each dimension shown here is in diameter. Already we mentioned 0.02 mm is the least reading here. 0.02 mm in diameter. So this 0.2 already marked as we can rotate this to 0.2. That means in this portion 0.2 mm will reduce in diameter. That means 0.1 mm reduce in radius. So directly we can give 10 division. 10 division means 1 mm. 1 mm we can give. So the 1 mm means the 1 mm will reduce in diameter. So after giving 1 mm, we can start the machine. Let me slowly we can move. This operation is called a training. So you can move the tool up to that line we already marked 35 mm length. So then return back to the initial position. So actually this workpiece is not an eccentric cylindrical one, it's an irregular surface. So some portion it will not touch irregular surface workpiece is here. So not an exact machined one. So we can roughly take the diameter. Almost at 24 point something. So we can give one more depth here. We can give 1 mm again. So 1 mm to 2 mm we can give. So just we can check the diameter here. It is 23.6. So we can move forward. This is 23.6. 23.6. So our diameter is 23. So you need to reduce 0.6 mm. So for reducing 0.6 mm, we can give 2.6. Now it is in 2, so we can rotate this to 2.6. So that means a 0.6 mm will reduce in diameter. So this is a final cut of the first operation, training operation. So the final cut, you need to make it smoothly. You need to move this cross carriage slowly and uniformly. So then you will get a good surface finish. So the first step already completed. The length is 35 mm and diameter is 23. So we can make the second step here. We need to make a step also here. The step dimension is 20 mm length and diameter is 21 mm. So again you need to mark 20 mm length. So you need to take 20 mm on the vernier caliper. So again same process using this tool. You can just set the tool to the tip of the vernier caliper. You can set the tool to the tip of the vernier caliper. Switch on the machine. You can mark the line here. Mark the line. So this length is 15 mm. Sorry, 20 mm length. So 20 mm length and that 20 mm length will reduce to 21 diameter. So again same process. Actually this machine is in, now the dial is in 22.6. So dial is in 2.6. Again from 2.6 only the dial you need to set to 0. That's we can reduce diameter. So we can set to this 0 again. So that's this touching portion is 0. So from 0 again we can give 1 mm. So how much diameter? 23 to 21 means 2 mm into reduce. So 1 mm already given. And you can move, easily you can move. So we can take the diameter here again. It is 22 now. It is 22. So again 1 mm we can give. So now it is in 1 and you can rotate this dial to all thing to 2 mm. So again 1 mm depth in diameter. You can check the diameter. So almost 21 mm. This is exactly 21 mm. So already we completed the basic operations. First facing already completed. So after facing you can mark the length, total length you can mark, that is 35 mm. So up to 35 mm you already be reduced to 23 mm. Then again you mark the length of 20 mm and up to that 20 mm you reduce to 21. So this is a basic training operation. So one more operation we left, that is the chamfering. So already we completed the basic operation, means facing, training, step training already we completed. Then one more operation left, that is chamfering. So the dimension given on the drawing is 2 into 45, 2 into 45 degree. 2 into 45 degree means you need to chamfer in the length of 2 mm, then angle is 45 degree. So for chamfering means it's type of taper training. So for chamfering we need to using this compound test. This is the compound test we already mentioned earlier. The compound test we can rotate to particular angle and we can move this dial, this wheel. Then using this wheel means the tool will move on that particular angle we set here. So 45 angle we can set, and using with this wheel we can rotate, the tool will move on that particular 45 degree angle. So we can easily do the chamfering. So for setting 45 degree, just loose these two nuts here. Using spanner, we can just loose it, just loose. For here also. You just loose it, and one dial is here. So now it is in 0. So we can rotate this to 45. So between 40 and 50, we can set one mark is here, that is in 45 degree. After that, you need to tight all nuts perfectly. Take 2 mm here. 2 mm is the length, chamfering length is 2 mm, already mentioned on the drawing. So take 2 mm and we can mark the 2 mm here, just mark the 2 mm here. The 2 mm already we marked. Then you can give the depth here, and no, do not use this wheel. This wheel only for the parallel movement we will get. So already we set the 45 degree here. So only use this wheel for that particular angle. The tool will move on the 45 degree angle. So we can give some depth. Then slowly we can turn. Each operation after that give some depth and return back and give some more depth. So we will get exactly 45 degree chamfering here, length of 2 mm. 2 mm into 45 degree. That's the chamfering dimension. So almost we completed the workpiece. So once again I will tell the important thing. First operation, we need to center the workpiece using this help of the circles, and we can use the surface gauge also. Fine adjustment we can do with surface gauge. So after centering, you need to fit the tool here on the tool post. So this is a work holding device called a chuck. The chuck, we can fit the workpiece on the chuck, and that we can fit the tool on the tool post. So after centering, you do the facing. First operation, you need to do the facing. So after facing, you need to mark the length. The particular machine drawing already given there, the length is given. That particular length you can mark. So up to that length, you can reduce diameter of 23 mm. The first diameter is 23 mm. So after that, you can mark the step. The step is 20 mm length. So up to 20 mm length, you reduce to 21 diameter. So that's a basic operation. After that, you need to do the chamfering also. Chamfering dimension is 2 into 45 degree. That is 2 mm length, and the angle is 45 degree. So for making that, doing that chamfering, that you need to rotate this compound dust. You can use the compound dust for using that chamfering, making that chamfering. So chamfering means the type of turning. So using this compound dust, you can rotate this to particular angle, a 45 degree angle, and using this wheel, you can machine that chamfering. So already we completed the machine. Then we can remove. So just lose this two adjacent jaw. You can just lose it easily. You can remove. So this is the basic operation for your exercise. Diameter and other thing. That is a basic operation about the lathe. The main operation: facing, turning, and step turning, and chamfering. Okay. Okay, we already completed the workpiece. So after completing, we already removed the workpiece from the lathe, and then after that we can remove the tool also. Just lose these two nuts. You can remove the tool. Then after work, you should clean the machine perfectly after working. So using this brush, you need to clean the machine perfectly. So everyone should do the cleaning after completing the work. You need to clean the machine perfectly. All the gateways and the check, all things you need to clean. You need to clean every chips That already machine time, the chip will remove from the workpiece that you need to clean. So while working, you need to perfectly you need to remember, you need to fit the workpiece rigidly. All jaws you need to perfectly you need to tight. Otherwise, while working, the workpiece will come out that may make some accident or something. And you need to perfectly you need to careful about the tightening of the chuck. All jaws you need to tighten it perfectly, and the tool also you need to perfectly you need to tighten. And you do not wear loose clothes and other thing while machining. And long lengthy hair, you need to keep it tight band and keep it inside your cloth. That's for a safety precaution. That's the main thing about this machine. They're very simple. You can easily complete your simple operation here. Workpiece is very simple, which is only 2 or 3 dimensions. Actually, while working, we'll give some tolerance also. For tolerance means for diameter, it is plus or minus 0.02, and for tolerance diameter, it is plus or minus 0.04, and for length, it is plus or minus 0.1. That's a tolerance. I can easily do with the vernier caliper. Okay, thank you.